Hi students, in session 11 text section 5.4 we will see arc length and areas of surface of revolution. ആദ്യം നമ്മൾ arc length define ചെയ്യും, അതിൻ്റെ formula derive ചെയ്യും, പിന്നെ നമ്മൾ areas of surfaces of revolution ചെയ്യും. So first arc length. So suppose y is equal to f of x. This is a function a less than or equal to x less than or equal to b. Assume it is continuous. So let us try a figure. This is x-axis, y-axis, a, b. Suppose that this is the function, graph of the function y equal to fx. I want to measure the length of this curve. So what we will do is I will partition the interval AB into equally spaced subintervals. So I will call x0 as A, xn as B, and this is the point x1, this is the point x2, etc. This is the point xn minus 1, B is the point xn, all are equally spaced, and this point, this is the point P0, this is the point P1, this is the point P2, etc. This is the point Pn minus 1, this is the point Pn, here is the point Pn minus 1. Now I want to compute the length of this curve. So length is equal to the sum of lengths of arc P0 P1. So I will denote it like this, arc P0 P1, namely this thing, arc P1 P2, it is this thing, etc. arc Pn minus 1 Pn, namely this thing. So length of the curve equal to sum of the lengths of these curves. Now what is the sum of P0 P1? Or in general, take the ith subarc or kth subarc. So it is pk minus 1 pk. It is the kth subarc. What is the length of this? Okay, let us draw another figure. So suppose that this is pk minus 1 and this is pk. This is the point xk minus 1 and here is the point xk. So this is xk minus 1, this distance. So it is delta x, it is the same for all subintervals. That means length of x0 x1 is the same as length of x1 x2, etc. is the same as length of xn minus 1 xn. These are equally spaced partition points. So length of each subinterval is delta xk, and this is change in y. So this is delta y. Okay, so this point pk is the point xk comma f of xk. F of xk is denoted by, let us say, yk. Similarly pk minus 1, What is pk minus 1? Pk minus 1 is xk minus 1 comma yk minus 1. That is pk minus 1. And what is delta y? Delta y is yk minus 1. yk minus 1. So now look at this triangle. By Pythagoras theorem, length of the hypotenuse is equal to square root of this length plus square of this length plus square of this length. So delta x the whole square plus delta y the whole square. It is not the length of pk minus 1 pk. It is the length of this hypotenuse. So length of arc pk minus 1 pk is approximately equal to this thing. Okay. So now let us substitute for delta yk. So this is equal to square root of delta x whole square plus yk minus 1 the whole square. Okay. Now